This series of videos discusses how to evaluate and compare biometric verification technologies, including key metrics, testing, and accreditation. To understand how technologies are evaluated, we must first cover the metrics against which they are tested. Here, we will break down biometric technology into components and explain how to measure the efficacy of each. Biometric verification technology comprises face capture, liveness detection, and face matching. The face capture is the first step and requires a software development kit, SDK, to access the camera on the user's device. Most biometric vendors offer an SDK with built-in features that enhance the security and user experience, such as metadata analysis, live user feedback, multi-frame capture, and challenge responses. Liveness detection confirms the user is real. Algorithms analyze the captured imagery for signs of spoofs, such as images, masks, or deepfakes presented to the camera. More recently, some liveness detection technologies test the imagery and analyze metadata for signs of spoofs injected into the system. Face matching software compares the biometric template of an individual's face and matches it to another image. This could be the image on an ID document or a previously enrolled image. We can evaluate the full biometric system by testing the false accept rate and false reject rate, abbreviated to FAR and FRR respectively. The false accept rate is the rate at which false claims are incorrectly accepted by the entire system. The false reject rate is the rate at which true claims are incorrectly rejected by the system. The false accept and reject rates give a picture of the overall system. Yet, for a more detailed evaluation, it's important to understand the performance of the individual components. For this, we must measure face matching and attack detection. Face matching is measured in false match rate and false non-match rate, shortened to FMR and FNMR respectively. The false match rate is the rate at which images from different individuals are incorrectly matched. In other words, the system mistakenly identifies images of two different people as the same person. The false non-match rate is essentially the opposite. It's the rate at which the biometrics of the same individual are not matched. Put simply, the system incorrectly identifies two images of the same person as two different people. To evaluate a system's attack detection capabilities, we measure the attack presentation classification error rate and Bonafide presentation classification error rate, abbreviated to APCER and BPCER. APCER is the rate at which attacks are incorrectly classified as genuine transactions. BPCER is the rate at which genuine transactions are incorrectly classified as attacks. It's important to note that attack detection comprises many algorithms, each with its own weighting, making it challenging to combine into a final score. Plus, the attack landscape is always changing, making APCER more of a guideline than a fixed measure. It may sound like the FAR and APCER measure the same thing, but they are different. FAR refers to the proportion of attacks misclassified as genuine as a proportion of all traffic, not just attacks. This depends not only on the accuracy of the system, but also on the underlying attack rate. A system could have a low FAR, but that may be due to there not being many attempted attacks. Let's say a system has 1,000 transactions. Of these, 50 are incorrectly accepted. The FAR will be 50 out of 1,000, which equals 5%. By contrast, APCER is the proportion of attacks misclassified as genuine as a proportion of the total number of attacks. Suppose the system has 1,000 attempted attacks. Out of these, 10 are incorrectly accepted. The APCER will be 10 out of 1,000, equaling 1%. This means that the FAR is the APCER times the attack rate. Therefore, even with a low APCER, which means the system is good at detecting spoofs, the higher the attack rate, the higher the false accept rate for the full system. This is to say that when evaluating biometric verification technology, organizations should dig deeper than false accept and false reject rates. While they can give an idea of the accuracy of the whole system, these metrics do not provide a detailed view of biometric matching and attack detection. Key takeaways. 1. Biometric verification technology comprises three components: biometric capture, liveness detection, and biometric matching. 2. We can evaluate the full biometric system by testing the false accept rate, the rate at which false claims are incorrectly accepted, and the false reject rate, the rate at which true claims are incorrectly rejected. 3. For a more accurate understanding of a technology's attack detection capability, we must evaluate APCER along with FAR. APCER is the number of accepted attacks as a percentage of total attacks. FAR is the number of accepted attacks as a percentage of total traffic.